to us, the Fuse one really stood out. It was the cost of the materials, it was the cost of the 3D print, but not only as a single print, but actually in the sense of a small batch production, was probably the most competitive option. Simple Design Works is an end-to-end product design house, and the mission of the business is to help businesses grow through meaningful, commercially viable innovation. The team is made out of industrial designers, product designers, and design engineers. 3D printing plays a big role for us, not only in the initial early stages where we have to prototype and test different options, but we've always been fascinated as a company in that space between prototyping and mass production. And we've seen a lot of inefficiency in that space, in the sense of certain companies would be forced to actually invest in soft tooling or commit significant amount of their budgets to tooling in order to be able to test and just get some feedback from the market. And this isn't great because you have to go back, you have to make changes to the tooling, there's lead times, there's costs involved, which is where the new sintering technology was brilliant from our point of view, to be able to take a product and produce a really cost-effective batch of prints on a very short lead time without committing to tooling or without necessarily being restricted to the criteria you have to kind of satisfy when you design an injection molding. That's a great opportunity. It gives you the option to manage risks and budgets a lot better when you design new product. It gives you the flexibility to introduce changes, to bring the lead time down and just take that fail fast approach and refine your proposition as quickly as you can. We see a lot of clients who move away from traditional manufacturing methods and they consider designing for 3D printing. And the reason could be different. It could be down to volumes and minimizing tooling cost, or it could be to do with the ability of taking market feedback and making changes to the design quickly. We've seen examples where the volumes would be low, so you would have 7 or 8 different plastic components, but you would sell, let's say, 1,000 units a year, and you can't really justify the tooling cost. So a lot of companies would design the internal structure of a product using 3D printing methods, having the ability to print in nylon 12 to create a structurally sound component with the properties not far off an injection molding without the tooling costs. Being able to produce small batches rather than freezing a lot of money in stock. We also see a lot of production opportunities to actually be impactful with this technology specifically. If we take the latest Fuse One printer, for example, and the print in place option, where we can produce moving components and fully build assemblies as a single print and deliver those, helps us actually produce assembly fixtures, quality control fixtures, measuring fixtures. We've looked at all the alternatives and we carefully studied the different manufacturing methods and the pros and cons, and to us the Fuse one really stood out. It was the cost of the materials, it was the cost of the 3D print, but not only as a single print, but actually in the sense of a small batch production, was probably the most competitive option. The structural integrity of the components was really, really good, and there was a good variety of materials we can play with. But also as a company, for us to be impactful and reduce the cost of those initial trials and help clients transition into the bigger volumes, the fact that the amount of manual labor was reduced significantly was a big factor. We no longer had to apply our hourly rate to finished components. The process was very quick, and it allowed us to be a lot more flexible when it comes to different type of applications, different industries, and support our clients at a very low cost. So we've seen companies that actually design with the mindset of 3D printing certain parts. So we could, for example, have a nice glossy external housing, but the internals, whether this is the chassis of a product or whether this is fixing brackets or hinge mechanism, it just gives us the opportunity to build a lot more convenience and build features that are normally difficult to mold, introduce cable routing systems to hinges or fixing points for sensors and so on. It just gives that flexibility, especially when the volumes aren't there, to be a little bit more creative with the design and look at how you can be more impactful, not only with the product and the function, but actually look at what service departments do, what production lines do, how we can streamline that process and remove the cost further. So the impact has been more significant than we expected, and we've certainly created a lot of appetite for this service and a lot of food for thought of how we can optimize things further. As a product design house, we live in a very fast-paced environment, and we're having to adapt to market changes fairly quickly in order to help our clients remain competitive. So what's really important to us is having a dynamic partner with industry-leading levels of expertise. We need someone who would come and understand who we are as a business, understand the opportunities for us to deliver more value, and give the right advice, whether this is a piece of equipment, whether this is providing consumables, whether this is providing the hardware. And we've had this relationship with Neo and Solid Print 3D and Solid Solutions right from the beginning. They're extremely personal, they feel like a part of the team. We've shared the vision for the business with them on a regular basis, and they gave us the right advice of how we can deliver that vision. So we're very grateful for their expertise and the help, and look forward to working with them in the future.